See a magnetic force on a current carrying conductor. Suppose you have taken conductor like this of length L. So, see here this conductor has length L. So, L is length of conductor A is area of cross section and N is number of electrons, that means free electrons per unit volume. Suppose current is flowing like this, in this direction I is going here and magnetic field is acting somewhere here, that is B, and this angle is over here theta. The electrons are moving to this side, that is with velocity Vd, that is called drift velocity. So, now electrons are moving to this side, current is acting flowing to this side and magnetic field is acting to this side. So, see current carrying conductor has got large number of free electrons and these electrons are moving in magnetic field. So, we can calculate force acting on the each electrons and then we can get the total force acting on the all electrons and that will be equal to force acting on the conductor. So, let us see here force acting on an electron, that is F is equal to, here we can write minus E, that is the charge of an electron, into Vd cross B. So, this is the force acting on an electron and now there are how many electrons? So, total number of electrons, that means free electrons in conductor is, that is N into Al. So, number of electrons per unit volume into the volume of the wire. So, we have got the total number of electrons here. So, we can get the total force acting on the electrons. So, we can write here F is equal to minus ENAL and that is Vd cross B. Here Vd is equal to actually drift velocity of the electrons. So, now here we can solve this or we can just replace by the different factors I and L. So, we know I is equal to A N E V D, we have done in electric current. So, this expression can be written F is equal to I L cross B here. We have taken L is the vector whose direction is along the direction of the current. So, the direction of the current and drift velocity are opposite to each other. So, this minus sign has been replaced and now we will be getting the force acting on the current carrying conductor is I into L cross B. We can also write F is equal to I L B sin theta. So, if you are taking theta is equal to 0, then you will be getting force is equal to 0, 0 or 180 degree. In both the cases magnetic force is 0. But if you are taking theta is equal to 90 degree, then theta is equal to 90 degree, you will be getting F is equal to BIL, this is the maximum force. And in that case, if you are getting this maximum force, its direction can be determined by Fleming's left hand rule also. In the Fleming's left hand rule, what you can do here, just stretch your forefinger, center finger and thumb of the left hand in such a way all remain perpendicular to each other. If the current is flowing in the direction of the center finger, magnetic field is acting in the direction of the forefinger, then the magnetic force will be acting in the direction of the thumb. So, this is about the magnetic force acting on a current carrying conductor.